Hello, and welcome to Lecture 5 of Phys 1104. In this video, we're going to look a little more at the rules of vector algebra. So here is this vector, and I've imposed a grid on it, which has allowed me to write down that it is 4i hat plus 2j hat in meters. And you learned to do that way back in an earlier unit of the course, and so hopefully you can see that. If you don't, then go back and review that video lecture. In any case, this form of the vector is what we call component form. It's also sometimes called Cartesian form, but there's another way we can represent a vector. A vector has a length or a size, which we call its magnitude. And it is also pointing in some direction, and you can define that direction in many ways, but a conventional way is to give the angle counterclockwise from the direction that the positive x-axis points in. And so once you have defined the length of a vector and the direction it points in terms of an angle, you can just write it down as a length or size and that angle. And this is called the magnitude direction form of the vector, and it's also often known as polar form. I'll just comment that if you remember all of your trigonometry, then you know exactly how I got the magnitude of A and that angle, theta. If you don't remember how to do that, don't worry, I'll show you in a few minutes. Here are a number of vectors, and we know them in component form. Now, some students seem to think that if you have a vector in component form, you need to find its magnitude and direction. Really, you don't. Unless there's some specific reason for needing the magnitude or direction, you might as well leave it in component form. Most of the time, component form is actually the most convenient form to have a vector in. However, sometimes you do need to know the magnitude and direction, so let's see how you do it. And it's just trig that you've probably learned before. So first I'm going to find A with no vector symbol. So remember that what we mean when we write the A with no vector symbol is that we want the magnitude of A. And you know how to do this because here's a triangle, and you know this side is 4 and this side is 5, and the magnitude of A is just the length of this side, and you've known Pythagorean theorem for years and years and years. Now, the other thing we need is an indication of direction, and the easiest thing is just to get this angle here, because we usually state the direction of a vector in terms of its angle from the x-axis. So I'm going to call this theta A, the angle for the vector A. And what we know is that tan of theta A is the opposite over the adjacent. So that would be AY, the y component, over AX. There we go. And so that tells us that we can find theta A just from the inverse tan of AY over AX. And so that's 5 over 4, where those are both in meters, so the meters are going to cancel and I don't need to worry about them. And that's about 51.3 degrees. Let me just do that again with B. And then I'll define theta B to be here. So by convention, angles counterclockwise from the x direction are positive, and so this will be a negative angle by convention. And we're all done. Now we know both of these vectors in terms of their magnitudes and directions. Now let's go the other way. Let's start with a vector that's in magnitude direction form, and let's get it in component form. So let's say there's a football here. Actually, the way I've drawn it, it looks more like a lemon. So let's go with that. Someone's throwing lemons. So here's a lemon that somebody's thrown, and it has a speed. Note I didn't put a vector symbol here, right? This is a speed. It's going 15 meters per second, and it's directed 30 degrees from the vertical. So we could write the v vector, the velocity, in either of these ways, say, and a variety of other ways, and let's convert that over to component form. So the first thing to do is just draw a little more. Before you do trigonometry, you should know what the triangle is that you're talking about. Never do trigonometry without drawing the triangle. So here is V, and here are its components. And we want to know Vx and Vy, and we know that this is 30 degrees, and we know that this is 15 meters per second. So we can just do usual trigonometry. Vx over V, that is the opposite over the hypotenuse, and so that's sine of the angle we're talking about, so 30 degrees, right? And so Vx is V sine 30 degrees. So that is 7.5. Similarly, you can see that Vy must be V times cosine of 30 degrees, more or less 13. Okay, and there. So to go from magnitude direction to component form, just draw the triangle and do the trig.
Let's check your understanding. Have a look at the diagram, which shows a vector, and it gives you the magnitude of the vector, and it gives you an angle, which tells you which way the vector points. Figure out how to write this vector in component notation.